This one focuses on what most people call data analysis, but is just as commonly referred to as data discovery or data profiling. Um, let's think about how you would sort of check out a data set if you're first encountering it on the wild or whatever. Anyway, there's going to be some physical characteristics. It's going to be able to take up a certain amount of disk space. It's going to have a name. It may have some lineage information. It may or may not be complete. You may be able to tell how old it is, whether it's reasonable for fulfilling the purpose for which you're intending to use it. Uh, if you're extra lucky, you might have some metadata, some column definitions, tell you some additional information about it. This gets us into some database-ish types of properties. Um, really fortunate, you may have understanding of differences in the way rows were connected and collected. That's also quite important to the whole thing. And the finale of it is that you would end up with cross-table connections, that you would understand how this thing worked as a sum of all the tables working together rather than just individually. And unfortunately, it's fairly common for organizations facing these type of challenges to look to technology to solve most of these problems. I'm going to dive into a Dilbert here real quickly just to emphasize the disdain for which I hold that approach. Sales guy says if you buy our system, it will pay for itself in 3 years. Dilbert, who's the smart engineer, says approximately how much does it cost? Sales guy says, well, it's hard to say. It depends on many factors. Dilbert says, fine, just tell me how much money it will save annually. The guy says, oh, you'll save $10,000 per year. Dilbert says, well, then if it pays for itself in 3 years, it must cost about $30,000. That was a little trick I call math. And unfortunately, most vendors can't do it because the technologies by themselves are really just a one-legged stool. And that some form of governance is the major means of preventing one-legged stools. Only when you have a three-legged stool do you have something that's architecturally sound, and that three-legged stool consists of people, process, and technology approaches. But for this lecture, we are going to talk a little bit about the technology aspects of it. So when you're looking at an existing environment and sort of walking into it for the first time, there's a lot of unknowns. And the typical amount of time it takes somebody to get familiar with their environment is 3 years. That's productive in there. But that's not a very good set of numbers there anyway. Eventually, some of these names form on here, and these may or may not mean anything to you in particular, but they're sort of typically part of everybody's environment in one form or another. And there's some base data structures that we can describe here real quickly, just to give you an idea of the variety. The simplest one is a flat file. It's a Word document, if you will. It reads from start to the end. If you were reading a Word document or any type of flat file from the start to the end, looking for a person whose name was Townsend, you would proceed down there and compare each one until you found the right one. A advance of that was an index sequential file where asking for the person Townsend is, they would say, well, look, you don't have to look in these records because we have built this thing we call an index. And this index says you can start looking for the T's right there and get an answer response more quickly than you would in the flat file format. Network database also gives you this, but gives you the ability to directly access this information. The question is Townsend a cook? The answer is yes, they can directly go to that information. Hierarchical databases are very similar to network databases. They also provide the same type of call and response here. On the network side, you can connect things directly to each other. In a hierarchical, they can only have a parent and child relationship between them, making it both easier and at the same time less capable of doing other things. But again, fairly similar and interestingly enough, not usually introduced. These two databases run so much of our existing infrastructure today that if you took them away from the large organizations that run them, the entire set of functions that they do, the banking system, the Defense Department, many things like this would stop running along these lines. Not realizing that these things are 10 times faster than relational database technologies, which is sort of what we've spent our time learning and doing because it's easy to teach and relatively easy to understand. Relational databases say that these records can be combined using relational algebra, which makes them very nice for problem solving type of activities. Real world activities does require some expertise in there. And then there's a final category of these things which should also bring to your attention called NoSQL. It's a very poor choice because it means not only SQL, which you wouldn't get from looking at the name there, but it's an all modern alternative to data that doesn't really fall into the relational paradigm and is useful under certain circumstances. It's what you'll hear is the data lakes these days. A collection of modern databases is an approach, a more direct approach to the relational pattern. Everything in there requires an individual key is essentially the way it works. And having access to that key does some things to the data collection. It vastly increases the granularity that you're using. It requires additional expertise and capability, depth of bench on the part of the host organization. The database really does not evaluate its data when it's internally. It's strictly a storage mechanism, with relational databases do add some more value beyond that. And it permits additional limited ways of interacting with it, which is a short way of saying that it doesn't do as much as the other ones do. But again, different trade-offs, different approaches, different tools, both have proven useful at this point. So back to our sample environment here, we start out and to sort of look at they've got three different type of database technologies, and there's some fairly large numbers there and some larger numbers there. And goodness, this is going to take some time to understand this. And then the other question that you always ask in these circumstances is to see how these things have evolved themselves over time as they've been used in the organizations. And finally, there's another set of clumping that you need to understand, which is that these fall into different categories of organization types. So how did we go about the process of making sense of this and providing support from a data perspective to large collections of data at this level of approach? The answer is that we used to do it an old way. I mean, I had the job at the Defense Department to headed up this entire effort. It was old. It was manual. It required us to sort of brute force the way we were doing it. It was dependent on a repository, the case tool technology that we were using. It was completely indifferent of quality. It was not repeatable under any circumstances. And literally what we were doing was going to these locations and sitting down with what we called these subject matter experts and asking them questions, and in real time deriving the answers to those questions expressed in a form that we could use them, the data models that we needed to have, very, very easily. And this was a fairly expensive process. The new approach that we're going to teach here is what we call semi-automated. Everybody wants it to be automated, but it is semi-automated. It's an important distinction. It's an engineering-based approach, which means it doesn't need a repository. You can integrate the process of quality analysis in with it. It's repeatable and it's current, which means it also is accurate in terms of what you're attempting to pull. These are called data discovery profiling analysis technologies. A woman named Dina Bitton put them together with some research through the Defense Department early on. These technologies give us the ability to deliver 10 times productivity at understanding existing data over manual approaches, and allows the profilers to quickly form what we call hypotheses. So if yes, then this. If this is true, then this is true. We need to know whether these are cause or correlative type relationships here. And around these data structures, it's important to do that because then we can present these series of hypotheses to the SMEs in a very short and refined session without having to teach them as much or require as much of their valuable time as we have had in the past, which allows us to infer the data structures very, very quickly. And we had some very good pioneers in here. Dina went on to form the company Evoke Software. I worked briefly with them as well in the process. Our value proposition all the way around for these is that if I was doing this manually, as I was for the Defense Department, I was spending 3 chunks of time each week, a morning, Wednesday, Monday, and sometimes a Friday afternoon session preparing the model. And as I would spend this much time with my team preparing the information that we needed to glean and to make progress towards and all this, this limited the amount of time I could process that information. And there were a couple different limitations on it, but main was the amount of work that we could do was severely limited. So if I prepared 3 times a week, I would need the model refinement sessions to occur. These would be the times I needed the subject matter experts to be there in very significant, expensive amounts of time, at least 7 times during that 10-day period. Excuse me, 10 period during the 1 week period. There you go. Anyway, one of the things I say to the groups that I work with is I need you to write down the names of the 10 associates whose time is so valuable that you could not spare them for any more projects. And they do, and I turn it around to them and say, those are the ones I want on the project here for us because their knowledge will allow us to do this quickly and efficiently, where somebody else will end up going back and asking them the question anyway. We might as well get them directly involved. And I can do this on a 2 afternoon a week basis, whereas the old approach was like that. And in that process, working offline in what we call model preparation time, we can do the things that need to be done to make most productive use of their time very, very quickly and surgically as opposed to completely as we did in the past. So I'm going to switch the lecture here now to look at the tool that we use. This was Dina's product that she created. Dina created the company of Oak Software, and they sold this product called Migration Architect, and it was fun, and it still exists in forms of one another. What I want you to understand here is that you're looking at a series of attributes starting with emp ID and down to hnum that are the column names for the database called employee info. And when you look at them on the side here, in the actual tool itself, it shows that order date and order number and shipping date and PO number and last name and first name are the attribute names, and that there are a number of records that are distinct from that. In order number instance, it's 197, and order date is 528. So this tells you out of so many records that they have 1,573 in the sample, how distinct, how often they occur, how regular they are, how common they are. All of this information is good to look at because it gives you the ability then to look specifically at it. And in the workstation that they had set up, you could click on these things and get the information. Obviously, we don't have the tool, so you won't have to learn and do any of that, but you can do these types of activities with Excel. And so you sort the records in certain fashions. One of the things that the tool would do was a little bit of inference in here too, which again, you can program the spreadsheets to do only if it's useful analysis for you. Shipping date, for example, occurs in a character of 12 format, which is a date type form that the system infers from it. And unfortunately, it's also determining that the date and time in the target field is incompatible with that because of the types of data that it needs to interchange, and it's just not a good fit. It won't work when it tries to move it. Also, that infers that the null rule is okay. That's something else more complex. We don't have to address it on this lecture, but just remember null is a lot of fun to work with. So when you look at the hnum, line 31 of this particular screen here, you'll see that there are 234 distinct records out of 250, giving us a high distinct ratio. And it tells us what are the ones that are not conforming in that sense. And we can double click on them and they show up below, where I can see each of these are phone numbers or social security numbers or something. And we don't know at this point. H number, home phone number probably is a good inference, but never a certain bet. And you say, oh, there are 3 instances of 602, 7897200 in there. I wonder which one gets the long distance bills and which other ones are causing problems for our customers, or whatever the particular source of the question is that you're trying to investigate. And you can see how quality works its way in there as well, because when you do this type of profiling for each of the rows, you can start to understand the data in a manner that allows you to look at something like, I see a pay code here in row 5, attribute 2, inferred minimum value with an asterisk as a pay code. And I just wonder, why would an asterisk be there? In the past, we had to call the subject matter experts into the room and ask them the question, explain to them the context we were asking them the question, and a very slow and inefficient use of their time. Now we can form a hypothesis because one of us remembers, oh yes, asterisk and pay code, somebody mentioned to them, but let's just look at this. I could pop up a frequency distribution of everything that's in that value of pay code in there, and 11% of them are asterisks. And I can recall somebody telling me that with 11% of the pay force, that was in the UK. And sure enough, if I double click on that 557 there, it'll start to show me the values that come up. Now, again, we don't expect you to get into this kind of analysis for this exercise, but you will at least see the types of things that you can find by doing this sort of data profiling analysis. First little demo quick here is a piece I'll just narrate over the top. Again, it drops down for these records, and first thing we're going to do is read the data from wherever it was coming from. We would hopefully have it already in a database, and we'd want to pull it from that database. And one of the nice things about it is you don't have to read the entire piece, but that you can profile it according to samples, and you learn a little about sampling theory in the process. It's speeded up here for, demo purposes. That's all. Usually it's a fake, but were you connected to the server, it might take some time. We used to let them run over the weekend. That was before we got really good with parallelism. You'll notice that it's pulled up a number of different attributes about each of the various pieces of data that it's looked at, the various metadata about the data that it's pulled. Again, it's a documented max value, an inferred max value, and a minimum max value, which is null records, number of distinct, whether something can be null or whether it has to have a value in it, kind of important on all of that. As you look at these things, for example, when you see that, the percent unique employee ID and social security number both being completely unique, they may be good candidates for a key. We'd have to do further analysis to double check, compare them, see what was conforming, what was not conforming, whether they fit correctly into the categories that we were trying to find out exactly what it was. Again, we may be looking at different types of values, different ways in which people have recorded the data over the years, ways in which the law has required the data to be recorded, all of which can give you different pieces. Again, the goal of this is to understand that if you rank and use your spreadsheets carefully, you can start to understand bits about the data. If you're doing day trading, you would maybe expect margins very thin and not with lots and lots of zeros following them. So look for things that are reasonable in that process, and you can do all sorts of that type of work. You may want to come back and watch this a couple times just to get a sense of it. So that's our first one is column profiling. Next one is what we call dependency profiling. And you may, after you've gone through and done some column profiling, come up with a screen that looks like this, where it says the determinant is customer name and order date, whereas the dependent is the state shipping. And you say, I wonder whether that would be a piece that would be, true or not. The system may decide it's true, but the system may also be too smart for it, which is again why you want the person in the process. When you do discover those relationships that are true, you promote them, and the model understands then that there's a good subset of this data that it has inferred that is actually true and valid, and it will keep that as the logical data model. And when you do that, you end up with a ability to say promote this, promote that, and these things. And in this case, it's saying that the team that's looking at this has decided that order number, order number is the determinant, and the dependent is purchase order number. Again, order number also appears to determine last name, first name, customer name, et cetera, which, according to the business practices, may be perfectly true. So let's go to our second demo then about dependency profiling. Again, goal here is just to understand what can be done with the type of analysis, and if it can be automated, you can put it into Excel. So again, the things that are hypothesized by the system, which is really nice, is that the employee social security number determines the employee's current basis, EEO. Those are job code depending that. Anyway, yes, job code. It comes up gray, by the way, to say maybe you have a level of currency that you can set, 5% or whatever. The key again here is that you decide that the determinant is job code and the dependent is current title, and that's the way the world should work because that's the way the data should be. And it says, well, what data is unsupported with that? Let's take a look. Conflicting data. Well, look at this. If you let people enter the data, it becomes messy. 8071 is either a systems analyst or a sysanal. And 8070 is a systems analyst or a systems administrator. And 8056 is a programmer analyst, programmer anal. Again, just can't make this stuff up. So yes, the data is right. It's just conflicting. We're going to add it to the model. We need to go back and correct the data in production, whatever that happens to be there. But we'll accept these changes to the model and be able to create, again, this larger set of data, and you'll notice it comes out in the model, it's true, and yes, it's in the model. So you can go through methodically and examine the types of relationships that you have, that when one thing changes, another thing changes, and determine whether or not these things are true. Again, these are a series of hypotheses that you're presenting to the subject matter experts in brief, twice-a-week sessions, and the goal on their part is to prove you wrong, which makes it kind of an interesting exercise. All right. Last piece of all of this then is what we call redundancy profiling. And think of it this way, the system's pretty good at identifying overlapping values. Sometimes we're good at it, but the system's real good at it. And it's looked here and said, hey, in this particular situation, I've got some everything in supplier ID as a subset of employee ID. Is that good or not? Well, I don't know. So again, it's one of those things that the corporate policy might be there, but you've also got a data structure that supports it as well. And so you may dive in a little bit further and say, look, what's going on in the area of looking at redundancy here? So the record here is order records and employee ID. Looks a whole lot like ship by ID. So their overlapping is 40%. Good, bad, I'm not sure. We'll at least do the investigation. Notice, though, with the tool works, you can show the overlapping values or the non-overlapping values. Again, the specifics on each side of it. We can say that can be a synonym if we decide that's a correct rule, and it should work that way. And by creating synonyms, we're now starting to draw relationships between different tables within the system. And of course, somebody's already done that for us on the other side of it. But nevertheless, it still gives us the ability to come up with a rather complete view of how the data is integrated and related to each other, what we call systems view. Now, that again is a very high level description of the types of analyses that can be done. The whole point of watching this is to inspire you to do the kinds of things that you have, and most importantly, share them with everybody else so that everybody can learn from the types of analyses and we don't have to reinvent the wheel 31 different times around here. All right, and one last little quick bit on the lecture here. There's another component to all of this, which is that you could also use the same basics process to automate the process of, semi-automate the process of business process discovery too. And this is oftentimes very useful, particularly in the data, since we do such process reengineering oriented work. The benefits of doing it from a semi-automated approach is that you get holistic perspectives on the roles and the value creations, and customers are able to directly understand the inputs and outputs and gives a shared understanding of the entire process, which speeds up the process, decreases costs, increases compliance. It allows us to increase the throughput and the output, and results in good IT systems documentation. You might say, well, what is it that you have to put in? The answer is quite cleverly, this company called QPR has developed a web-based company that you input software as a service, a log file, and it takes the log file, and from the log file, it does not derive the process model, for goodness sake, and they don't claim to. But would you rather have this as a starting point for your process modeling efforts? The answer is super. So look, everything I've spoken about tonight in this quick little lecture is that it can be replicated, that it's an approach, it's a method, and we can learn to do it well. And that's really the key, is to don't be frustrated because it starts off difficult. It's just like everything else. We'll practice it for a bit and it will get better and better, but understand there is a required but necessarily and insufficient by itself a three-step approach to getting there. You have to go through the column, the dependency, and the redundancy profiling in that order, or the entire approach is ineffective. That you could categorize the work into really important and unimportant Pareto-based piles, that you've got to zero in on that piece that's going to give you the best results as a group, and discard other stuff. Then learn how to divide and conquer, work as a group, but you can't stop and celebrate there. You've got to do some real good work on recombining, understanding, analyzing the whole, seeing the forest for the trees, and then with that re-understanding, lathering, rinsing, and repeating the process.